Okay, hello students. Am I recording? Yeah. Fine. So we are now going to start with ellipse. Okay. So we have so far studied circles, parabola, and I hope you have studied hyperbola too. But I don't know because as far as I can see, some of you might have directly skipped into ellipse. In which case, you don't know what is hyperbola. Right? So I will be teaching you quite a few basics about ellipse. Okay, just the way we did with the other conic sections, and then we go with the exercise questions. Okay, now this is an ellipse. You're supposed to draw it with freehand. It looks something like this. Okay, I might not be neat, but just look at the basic shape. Okay, it's given over here. So an ellipse is a locus of point which moves such that its distance from a fixed point known as the focus. Okay, and its eccentricity is less than 1. What is eccentricity? See, eccentricity in the sense, for instance, you already studied this. The eccentricity of the eccentricity of ellipse is given by under root of 1 minus b square upon b square. Basically, eccentricity, what is that exactly? That is nothing but the distance from the focus to a fixed line. Okay, the line, what we call the directrix. Okay, so if you got a line over here, a fixed line, and you got a fixed point, and you got a generative point P. Okay, this point being the focus and this line being the directrix. Then the ratio of this point, okay, the generative point, and its distance from the focus to the directrix, and that is what our eccentricity is basically. So in other words, if I just made a mistake. Okay, if you just take this particular ratio, okay, you can see from my cursor over here, from P to S and from P to line D, that is perpendicular distance. This over here. This distance, that is perpendicular distance, you're supposed to draw it in this way. Anyway, a perpendicular distance. I'm not able to draw it due to some technical issue over here. But this distance, okay, and this perpendicular distance. Now we get it. This perpendicular distance. Given that this is perpendicular. So the ratio of these two distances is what we call the ellipse. And what is the ellipse of circle? First of all, we've already studied this. Ellipse of pair of straight line is infinity. Ellipse of circle equals 0. Ellipse of, sorry, it's not 0, it's 1. And ellipse of a parabola is less than 1. This is 0. This being 0, this is equal to 1, and ellipse of the eccentricity of an ellipse is less than 1, as we mentioned over here, and the eccentricity of a the hyperbola is greater than 1. Yeah, this we've already studied this thing. I shouldn't really discuss it again. But yeah, and the time its distance from a fixed straight line known as the directrix, we already know this. The constant E is called the eccentricity of the ellipse. So where the eccentricity is less than 1, or the ratio of these two distances is less than 1, we obtain a ellipse. And the general equation of ellipse is this: x square plus y square, x square upon a square plus y square upon b square is equal to 1. Now this particular equation, the uniqueness is this equation is same for both the cases of ellipse. Now you are basically going to study two different cases of ellipse. Let me just discuss over here. One case of our ellipse is going to be this way, somewhat like this. Okay, along the y-axis. Okay, this is going to be your directrix and everything. The other case that we are going to study is going to be like this. That is along the x-axis, with this being your directrix. Okay, so these are the two cases, and for both the cases, the equation is the same. Okay, So the equation is x square upon a square plus y square upon b square is equal to 1, where a is greater than b and b square is equal to a square into 1 minus e square. Okay, we've already studied all this, it's not really important. And the center is c0, 0, and that is what the origin is. We got s, and what is s over here? S is the focus, and the particular thing, what do you say, the coordinates of focus is plus or minus ae, 0. It can be written as plus or minus ae, 0. Okay, this is the coordinate of focus. Why do we say plus or minus? Now this is interesting because ellipse has got two foci. Okay, so one of the foci being, for instance, we take the case 1 of the ellipse, okay, along the x-axis. Then one of the foci is in the positive x direction. This would be one of the foci, and this would be another foci. Okay, and this would be x. The s over here would be minus ae, 0. Okay, and the s over here would be plus ae, 0. Okay, so we got two foci in case of the ellipse, and this is the center, obviously. This thing over here is the origin or the center. Let me again draw it over here somewhere. This is our ellipse. Okay, in case of let us consider the case 1 ellipse, for instance. So you got the x-axis over the y-axis over here, the x-axis over here. So this will be your two directrices. So you got two directrices over here in case of an ellipse, unlike the parabola. That is the first thing you need to note down. And you got two foci. Foci, or you got one over here. You got one foci over here and one foci over here. This s would be positive, that is plus ae, 0, and this s would be negative or minus ae, 0. And this would be your center 0, 0. Okay, so these are clear now. Okay, let's move ahead. Now what does it say after this? Z1, Z1 dash. Where is your Z1, Z1 dash? Over here, yeah, this thing. Z1, Z1 dash, and Z1 as a Z2, Z2 dash. These are the two directrices corresponding to the foci S and S dash. If I call this thing as your S dash and this as your S, then this would be my, according to the figure, this would be my Z1, Z1 dash, Z1 and Z2 dash, Z2. Yeah, so this is what the picture over there, even over here, actually depicts. Now the next point given to us is the equation of directrices. Now the equation of directrices is given by ae, 0, I mean a upon e, but over here we got another complication. Since we got two directrices and both the directrices are in the positive and the negative side of your x-axis, or in case of the second ellipse it's in the y-axis, we say it is plus or minus a, 0. I mean a upon e. Why do we say plus or minus? Because over here this would be minus a, minus a upon e, and this would be plus a upon e. Since it is in the positive, now this would be your positive x-axis, right? And this is your negative x-axis, your positive y-axis and your negative y-axis. So that is the reason why we have different, like we got two directrices, we got two foci, that is the basic reason for that. Now these are the two vertices, a, 0 and minus a, 0. Where do we have them? We have a, 0 over here, minus a, 0 over here. We got b, 0 over here, minus b, I mean the inverted one. B, 0 over here and minus b, 0 over here. Okay, so in the diagram also over here we call this a, 0. So this would be minus a, 0. This would be a, 0. So we call this as point A, we call this as vertex minus A. Similarly, this would be vertex B with the coordinates b, 0, and this would be minus B with the coordinates minus b, 0. Now you could tell me if this is A and this is A dash or whatever, minus A or whatever you call it. Okay, let's just leave it for now. Okay. Now over here we say this is AE, right? This is AE, 0. Okay. So since it's AE, over here it has to be 0. Even here it has to be 0. The y coordinates remain the same because we are going perpendicularly up and down. Over here also the y coordinate is the same, so we move perpendicularly up and down. Now what can we say is, the line AA dash joining foci in the major axis has equation y is equal to 0 and length is 2a. Line joining B dash, okay, so you got AA dash and B dash, these two things. Okay. And they have been given equations. Now why the equation is quite self-explanatory, right? Because over here, this line over here, A dash as we call it, okay, A dash and B dash. So now this line over here is in the x-axis, and since it is in the x-axis, we denote it by y is equal to 0. That is the equation we have for x-axis. And since this line is on the y-axis, we denote it by x equals 0. Clear? So we got two of these. Now, and then distances. Now distances are also quite self-explanatory. We got this as a, okay, and this is minus a, right? And this would be your plus a. So this distance over is again a. So a in the positive direction, a in the negative direction. When you're adding it up, you're going to get something which is 2a. Right? Both are a ugly at the same time. Like one is minus and one is plus. So the bottom line would be that this distance is equal to this distance. Obviously it has to be because it's a, what do you say, ellipses. Now look at the equation. You can say how symmetric it is. Okay, I'll come to that later. But this is called, this distance is 2a and this distance is 2b. Now why did we say that these two are equal? Because it's quite simple. If you look at the symmetry of ellipse, how do you check the symmetry of ellipse? Look at the equation. For every single square term, I put a 0. Then what are the zeros I am going to get? For instance, if I put x is equal to 0, okay, so this thing will become 0. That means it is symmetric along y-axis. At y is equal to 0, this thing becomes 0, and that says that it's symmetric along x-axis. So it is symmetric along x and y-axis. So it's got two lines of symmetry, x-axis and y-axis. Two lines of symmetry. So along these two lines, it's going to be one and the same. Just the signs are going to get inverted because it is in the positive and the negative directions respectively. Okay. And now we got the lattice vector. Lattice vector, that's a plural of lattice vector. So the lines, these two lines over here is the lattice vector. Again, you got two lattice vector, or the two lattice vector. One in the positive x-axis, its equation is given by minus 2b square upon a, and one in the negative x-axis given by minus 2b square upon a. That is this particular thing. The equation for this one is minus 2b square upon a for this one. Yeah? Okay. So again, this is our first lattice vector, minus 2b square upon a, and this would be our plus 2b square upon a. Now what do you think would be the lattice vector for the inverted ellipse? Like I just spoke about another type of ellipse, right? I draw it, okay. Over here, what would be the lattice vector for these two ellipses? Now if you look at this, we can compare the same quantities again, in which case you would get, for this being the ellipse and this being the two directrices, I'll not be looking at that for too much. But again, the directrices, the equation is going to get inverted. So if this is A upon E, this would be B upon E, isn't it? So this will be something like B upon E. This will be minus B upon E. The entire thing A and B is going to get inverted. Over here, this would be B comma 0, minus B comma 0, A comma 0, minus A comma 0. And this would be, what is B dash, and this would be A dash, A. And center is going to remain the same. What are the other quantities we looked at? We looked at this distance. What do you think about the distance? The distance is going to be the same. This thing over here is going to be 2b, okay, and this is going to be 2a again, because the vertices are same, so there is no much difference over there. What about the foci or the foci? For S, yeah, these would be the two foci, okay. So if you're talking about this foci, it's going to be S, this is going to be S dash, yeah. And if you're looking at S, okay, the equation here would be BE comma 0. Why? Because we are along the B. Okay, we are along the y-axis or the B vertex as we are talking about. So it's going to be like S is going to be BE comma 0 and S dash is going to be B minus BE comma 0. That's going to be the vertices for the foci. Then we got the lattice vector. The lattice vector, where the lattice vector going to lie is going to be along with this. This is going to be along with the foci. And the equation for this lattice vector would be, now what was the equation over here? It was minus 2b square upon a. It will be minus 2a square upon 2a square upon b. So it will be minus 2. I mean this would be plus 2a square upon b. It will be minus 2a square upon b. Yeah. So these are the quantities we studied so far. So I hope you're clear with what are the particular terminologies and what are the quantities we were studying in ellipse. Now there is another alternate definition, but we don't need to study this because it's like you got so many stuff you're going to study in later studies. And then you got the general equation of the second degree. So the second degree general equation for ellipse is given by this particular thing. We are obviously not going to study that. It's of no use. It's just for the definition purpose. Okay. This is a square plus 2hx plus by square plus 2gx plus 2fy plus c is equal to 0. Now the funny thing over here to notice is, in case of the second degree equation for parabola, you didn't have an xy term. Just go ahead and check it up again. You're gonna have like you coming across the x terms. You're gonna come across the y terms, come across the a terms, b terms, c terms, and even AB, okay, BC terms, CA terms. You're coming across squares of all these, but you never came across an XY term. Now this is the uniqueness of an ellipse. In ellipse, you're going to come across a XY term in a second degree equation. That is the reason why over here we say for an ellipse, you got another equation. I don't think you got it over here. You don't even have it in your textbook, but this is one more equation for ellipse that says there's a condition. Basically it says something about let's see if I have it over here. Yeah, this thing. So it says b square upon a square into 1 minus e square. So this equation over here for an ellipse is only true for an ellipse, not for a parabola. In case of parabola, you had a condition, but that was not the same condition, right? You had something like xy, or this thing over here, this term. So 2hxy is equal to 0. If this is the true condition, then you're going to come across a parabola, and if this is not true, that is, if it is equal to 0, then I mean if it's not equal to 0, then you come across something called a ellipse or a hyperbola. So if it is greater than 0, it is an ellipse. If it is less than 0, it is a hyperbola. But in both the cases or both of the conic sections, you're going to come across this particular term, that is with an xy term, 2hxy. Now the next thing we're going to study about the ellipse is corresponding to point. Okay, these are not really required, so we will not look at that. The position of a point with respect to an ellipse. Now this is again, it's a part of your JEE syllabus, not there for you in math for 11th grade. So I think we are done with ellipse now. Okay, we studied what were the basic stuff. So here is a quick recap. There's one more thing about the major axis and the minor axis. I hope you all know it already. If not, just remember this term. This is called a minor axis. Let me do it with another color. This over here is called a minor axis, and the long one is called the major. Just because it's long and short, we call it major and minor axis. Here, so I guess we're done now. Let's not look at these solved examples. I'll just give you some more sort of solved examples from your NCERT book. Now look at this NCERT book once more. Just check if you can find something new over here. The section, okay, we've done all this, right? Just look at the ellipse part. In an ellipse, we've been given a definition. We've studied all this already. We've been given the equation. Now both the equations are same. If you look very closely, okay, we see that both the equations are the same. Okay, but in case of case A, okay, A is greater than B, and in another case B is greater than A. Or in other words, for a ellipse like this one, the one that you're seeing on your screen, A is greater than B, right? Because this thing over here is A, and this thing over here is B. This is B. Okay, the one you're seeing with this green color, this thing is B, and this thing is A. Obviously over here A is greater than E. But in this case you can see that B is greater than. That is the only difference, but the equation remains the same. That is the funniest part. Okay, you need to appreciate that. Now the main facts about ellipse, you studied all this. Yeah. Now this table is very important. You have to sort of by heart it, but you can go logically. I suggest you to go logically. If you go logically, if you try to understand why it is so, you will probably end up like by hearting this even without struggling for it. Okay. So having said that, let's look at the NCERT exercise questions for this chapter. There is only two types of question that can be asked to you in ellipse, mainly being the okay. Chapter is conic sections. Okay. Let's look at the NCERT questions for ellipse part. Let's just skip on to ellipse. Circle, circle, circle. That is ellipse. Well, I'll only be solving like two questions in your NCERT because it's quite mechanical. Like if you know how to solve these questions, you probably know how to solve every single question in the chapter. Okay. So now the first type of question that can be asked you is find the coordinates of foci, vertices, length of major axis, minor axis, eccentricity, length of lattice vector of this ellipse. Now in any of such cases, what you're going to do is first recognize what is A and what is B. Obviously we know the denominator of x square is A and the denominator of y square is B. Clearly from here you can make out that A is greater than. Now what is A? A is equal to 6. Do we have it somewhere? Yeah, over here. So A is equal to 6 and B is equal to 4. Just the root of this, right? Because it's x square upon A square plus y square upon B square is equal to 1. So A square is 36, A is 6, B square is 16, B is 4. Once you find A and B, it's quite simple. You can just like replace all this stuff. So for foci, for instance, you're just going to do is, okay, you need to find eccentricity before that, okay, because you need to have E for finding the coordinates of foci. So what is eccentricity? Eccentricity, okay, eccentricity for this case, okay, when A is greater than B. If A is greater than B, then the ellipse is like this, okay, and if B is greater than A, the ellipse is like this. So we've studied for this case, the eccentricity is given by 2b square upon A square, upon A. Yeah. So use this formula, you know B, you know A, you can find E. Once you find E, you can use the formula to calculate your foci. We know that foci for this case, okay, for this particular case, the one that's been given to us in the question, for this case, the foci is given by S is plus or minus AE, 0. Whereas in the second case, the foci was given by 0, plus or minus BE. Okay. So you need to know which case it is. So for that, just note this thing. First find out which is greater. First find what is A, what is B, which is greater. And according to that, you use the formulas. So now you have A, you have E, you just calculated right now. So you can find the foci, the coordinates of foci. The vertices are quite simple for this one. The vertices is just A, 0. B is given by A, 0. For the other one it was, I mean this is plus or minus A, 0. I'm not doing that. Okay. Plus or minus A, 0. Okay. For the other one it was 0, plus or minus B. So that's what you need to make it out. Okay. And now you have A, you can calculate the vertices thing. Major axis is 2A, minor axis is 2B. Okay. And what else is given to you? Length of lattice vector. What is length of lattice vector for this particular ellipse? We've calculated it over here also. The length of lattice vector came out to be 2b square upon A. Okay. So it was 2b square upon A. And then you can find the length of lattice vector. For the other one it is 2a square upon okay, so in case of our case 2 ellipse. So that's what you need to once again check out which one is more applicable for you. Next, they haven't asked a directrix over here, but in the next question they will ask you a directrix. So in case of directrix, you use this formula. for the case 1 ellipse and this formula for case 2 ellipse. So that's how you're going to basically solve all the questions of this exercise. Okay. So the second question is the same over here again. A is less than B. We're going to use the second case. Over here the A is greater than B. We're going to use the first case. A is less than B, second case. A is greater than B, first case. So that's just the way you're gonna go ahead, you know. A is less than B, second case. Okay, what I'm gonna do in this case is just divide this by 144. Question number 7, since you've been given an equation, divide it by 144 or divide it by just to make the RHS equal to 1. So that will give you RHS is equal to 1. This thing will give you equal to 1. And this has to be simplified. So it will be 36 upon 144 x square plus 4 upon 144 y square. Now this 36 and 144 gets cancelled, 4 and 144 gets cancelled. You need to find what the denominators are. Do the calculations yourself. You will end up with this thing, x upon 4 plus y upon 36 is equal to 1. So then you can calculate easily. A is less than B, so go with the second case. That's how you'll do the 8th question. Just divide this whole term by 16. So you get this 16 gets cancelled. So you get x square by 1 plus y square by 16 equals 1. Now again over here, A is less than B. So that's basically how you solve all the questions of this exercise. So I hope like the entire part about the ellipse was clear to you all. So I think we'll sort of close it over here. Okay? In the next class, we're going to discuss about what we call the hyperbola. And just trust me, hyperbola is same as ellipse. Just to give you an introduction or a little sort of a recap, we studied this was ellipse, right? In case of hyperbola, what I'm going to do is just take this as a half, okay? Cut it into half, like you're cutting a piece of paper. Just cut the ellipse into half and then rearrange it in this way. We just want to turn this, invert it in this way, you know. Just take this part over here, take this part over here, just invert it in this way, okay? And this is how it corresponds to. And we take this part, invert it in this way, okay? So once we cut it, we're gonna have something like this, okay? We're gonna invert it in this way, and that is what hyperbola is. So this particular thing over here, with these two being the direct breaks, is an hyperbola. And in case of the second type of ellipse, this is going to be the hyperbola. And that is the reason why every single expression in hyperbola, except the eccentricity and the equation, okay, except these two, every single expression is the same for a hyperbola. It's same as the ellipse. So it's going to be quite easy for you in this class. Okay, we'll look at that tomorrow. Thank you.